Welcome to the virtual practical test on vapor compression test rig. In this session, you will be able to explain practical relevance, importance, and the procedure of determining performance parameters of vapor compression refrigeration system. You will also be able to determine theoretical and actual COP by using vapor compression refrigeration test rig. In this experiment, we determine theoretical and actual COP, means coefficient of performance, by using vapor compression refrigeration test rig. So objectives of these experiments are: study vapor compression refrigeration system, explain performance of experiment, which includes experimental setup, observations, calculations, result tables, and conclusions. Practical relevance is: we know various low temperature applications such as domestic refrigerator, water cooler, air conditioners, automobile air conditioner, cold storage, ice plant, and central air conditioning systems. In all these applications, temperature at the desired space is maintained below the surrounding temperature. This is possible by the process which is called as refrigeration. So, refrigeration is process of removal of heat from the space or substance whose temperature is to be kept below surrounding temperature. One more definition of refrigeration is: refrigeration is the transfer of heat from where it is not wanted to a place where it is not objectionable. So in the refrigeration process, heat from the space at low temperature is carried by the two-phase substance called as refrigerant, and it is carried to the surrounding which is at high temperature. Now this is possible by mechanical system which is called as vapor compression refrigeration system. So major components of the vapor compression refrigeration system are compressor, condenser, metering device or expansion valve, and evaporator. So from the evaporator, low pressure and low temperature vapor refrigerant goes to the compressor. In the compressor, this low pressure and low temperature vapor is compressed. Thus, its temperature and pressure is increased. Also, its thermal energy is increased. So, the temperature of vapor refrigerant is going above the atmospheric temperature. Such high pressure and high temperature vapor refrigerant goes to the next device, that is condenser, where condenser rejects heat from vapor refrigerant to the atmosphere, and this vapor refrigerant is converted into liquid form, that is condensation of the refrigerant is taking place at constant pressure. This high temperature and high pressure liquid refrigerant is coming to the metering device or expansion valve, where liquid refrigerant is expanded by throttling process. In this process, enthalpy of the refrigerant is remaining constant and its temperature and pressure is reduced to a very low level. So from the metering device, low pressure and low temperature very cold refrigerant, liquid refrigerant, when comes to the evaporator space, then heat is absorbed by the refrigerant, that is liquid refrigerant, from the evaporator space, and this liquid refrigerant is converted into vapor. Thus, in turn, cooling effect is produced at the evaporator space, and the cycle is continued till the Temperature at the evaporator space is reached to the set value. So in this way, these four component working of the VCRS system taking place. Experimental setup here, which is called as vapor compression refrigeration test rig. So which consists of these all components. So here is a compressor, condenser, capillary tube as an expansion valve, evaporator tank, dryer, accumulator, suction pressure gauge, discharge pressure gauge, temperature indicator, energy meter of compressor and energy meter of heater, thermostat for compressor, heating thermostat, and high pressure low pressure cutout. Let us see one by one. This is a compressor, condenser of plate, fin and tube type with fan for force convection type heat transfer, evaporator water tank which contains heating and cooling coil where the cooling effect of the water is obtained, capillary tube, dryer, accumulator, suction pressure gauge, discharge pressure gauge, temperature indicator, energy meter, refrigerant flow meter, high pressure low pressure cutout, compressor thermostat and heater thermostat. So all these components are of vapor compression refrigeration test rig. This is block diagram of refrigeration test rig. Technical specification of refrigeration test rig are: rated cooling capacity is 600 to 750 watts. Refrigerant used here is R134A, which is called as tetrafluoroethane. Chemical formula is C2H2F4. Condenser fan motor is of induction type. Water calorimeter tank volume dimensions are given. Electrical supply at 230 volts with 50 Hz frequency with AC current. Temperature indicator is of digital type. While using refrigeration test setup, we have to take precautions. Refrigeration test rig should be placed in a well ventilated space. It should be placed on a level surface. It must have a stabilized power supply in order to avoid power fluctuations. Proper connection should be for overflow drain and feeding of water calorimeter tank. Standard operating procedure: connect the power cable to supply, fill the calorimeter with water up to overflow level, put the main switch on, put on compressor and heater switch and note down the energy meter readings for the desired temperature. Maintain the water calorimeter temperature steady by using heater thermostat adjustment. Record the readings with a time interval of 5 minutes. So here compressor energy meter reading, heater energy meter reading, suction pressure and discharge pressure readings, various temperature readings are to be recorded as per the procedure mentioned, and finally plot the vapor compression cycle on the pH chart. Now let us go to the conduction of experiment.
Vapor compression refrigeration system, it has four components: compressor, condenser, capillary tube, that is expansion valve, and evaporator. All these components are connected to each other by piping. This pipe, this pipe, this pipe, and on the back side some connections from the main pipe are taken for various purposes, to know the pressure, these two pressure gauges, to save, for keeping this compressor for safety purpose, this high pressure, low pressure cutout, and evaporator tubes are arranged here in the this is evaporator tank, you can say. In this water we are keeping. Why? Because in our domestic refrigerator we are keeping food, we are keeping cold drinks, we are keeping milk. That is what refrigeration load. Here we are keeping water and we are cooling the water. That cooling water effect, that is refrigerant effect, we can measure by the formula. And compressor work we can measure by using electrical, this energy meter. So in this, these are three wire-like, these are what? Thermocouple. Now these two thermocouples are connected. One thermocouple goes to this, where there is a display, temperature display. It will give us temperature of calorimeter. That calorimeter means which calorimeter? Water calorimeter. Okay. One thermocouple goes to control this heating thermostat. Means we are using here heater to heat the water to give the load. So this heater should up automatically when the desired temperature is achieved. So that thermocouple goes to thermostat. Here are two thermostats. One is a heating thermostat. One is a heating thermostat, and another is this thermostat which controls the compressor work. When in this chamber desired temperature is achieved, at that time compressor gets up. So this is another thermostat. Dryer prevents entry of moisture to the capillary tube, which goes to the capillary tube, and accumulator that prevents or ensures only vapor. Liquid traces cannot go to the compressor, because after the evaporator this insulated line comes to the accumulator and then it goes to the compressor. Here suppose some liquid traces of the refrigerant, that liquid traces will be prevented. Here baffles are provided, horizontal plates. These plates will arrest that liquid traces and only vapor will be allowed to the compressor. Thus compressor work will be proper, that is dry compression. Wet compression versus dry compression we have seen. There are some disadvantages of wet compression, that is lubricant may wash out from the compressor. HPLP cutout.